some testings too all over the world. So for example, we have our big testing area in Gramas in South France, and we make also winter testing in the north, in Sweden, in Finland. We go down to South Africa, where we come back 2 weeks ago, testing the M5 in South Africa. Because for our car it's very important that about the cooling of the cars. That the cooling, you can cool down the car, because on the other hand, if the cooling doesn't work, you have no chance to get such a high performance of the car, so much power of the car. And that's one main issue for testing here. So endurance tests, the cooling, and then in the last years, in recent years, more and more electronic systems came into the car. Started with the ABS system in the 80s and in the 90s, then the traction control systems in the middle of the 90s, and then we have rollover mitigation in the car, and we have so many systems now, electronic systems in the car, which must work together. And if they not work together, you feel, oh, on the right hand corner at Hatzenbach, something happened, I haven't expected. Then we look in our data, what may be the reason, and then, oh, that system may be responsible for that, then we make a change. I hope in the next lap you won't feel that anymore. And so, step by step, we refine our cars. And so the more and more demand is from our test engineers from the electronic departments, and they come over, and let's say 80%, 90% are only working on the electronic systems. The other 10-20% are working at the car, under the car, and that is the point I want to explain you now with the M5. We can lift it, and then we can talk about a little bit of technical.
So back there we have some brake rotors of the M5. They have a 400mm diameter in the front and 396 millimeters in the rear. I think this is our biggest brake rotor that we ever did. If you have a lot of power, you need big brakes. So this car is still a little bit disguised. So some details are covered.
So as a chassis engineer, it doesn't matter if you have a nice car, or if it's a blue color, or red color, or white color. For a chassis engineer, it's important what happens under the car. That it looks very good under the car, and then the ride behavior is very good under the car. For the chassis engineers, not only the struts, the bolts, end are important. For the chassis engineers, also the body is important. Because the body is one part of the chassis. It's the only connection between the front and the rear axle. You can have a superb excellent front axle and a super excellent rear axle, but when they don't work together, you have a right performance that you say, something is wrong. Huh? It's like a squeeze, and you steer in, nothing happens. 1, 2, and then the rear axle reacts. And that's all, it doesn't feel comfortable if you have a weak body. And so we take care that we bring in the forces from the street, over the struts, over the tires, into the body, and this at the same time front and rear axle. And so we need a very, very stiff connection from our axles to the body. And you see some plates here. The front plate here, the same at the rear. This is new now by the M5, because our rear axle is now connected directly with the body. There are no mounts usually from the rear axle to the body. It's like in the race car, the GTS has the same system. It's connected directly to the body. And this gives us now the possibility to connect our struts from the body, from the underfloor, directly to the rear axle. If you have there a joint or a rubber, you will have a problem. You can't do that. So now we can connect it direct to the rear axle, and that gives us a much stiffer body here at the rear. And this combined with the plates here, with some holes in it, that we have a good airflow, provides us a very direct response from our rear axle. And this is a very immediate and direct response on the steering behavior.
Bitte das mal ganz kurz auf Deutsch, ja? Ich habe nur 60% verstanden.
Also wichtig ist natürlich auch, dass wir eine gute Verbindung haben von der von der Vorderachse zur Hinterachse.
Ja.
Wir sehen das als Fahrwerksingenieure als ein Fahrwerksbauteil an, die Karosserie. Die Karosserie verbindet mir Vorder- und Hinterachse miteinander. Und dann ist es wichtig, dass wir natürlich die Kräfte, die von der Straße ins Fahrzeug reingehen, gut und direkt übertragen können. Wenn wir also hier Kräfte haben, wir haben manchmal Aufstandskräfte, wenn wir zum Beispiel Tiergartensenke fahren von 20 Kilonewton, das heißt 2 Tonnen gehen da auf ein Rad drauf, was wir messen. Und diese 2 Tonnen kann man sich mal vorstellen, wie sich da eine weiche Karosserie verbinden würde. Und darum ist es wichtig, dass wir eine sehr steife Karosserie haben und auch die Kräfte an den richtigen Punkten in die Karosserie einleiten. Es nützt nichts, wenn da hinten alles bocksteif ist und irgendwo im Mittenbereich hat die Karosserie eine Schwäche. Ja, und das ist dann wie ein Gelenk, wo dann das Fahrzeug nicht reagiert und dann das ganze Fahrverhalten mit einem Schlag dann zunichte macht. Darum ist es jetzt wichtig, die Kräfte an den richtigen Stellen, wo also auch die Struktur von einem Fahrzeug steif ist, da einzuleiten. Und wir haben hier gerade im Fersenblechbereich von der Karosserie recht steife Anbindungspunkte, genauso im Schwellerbereich. Und da schauen wir natürlich jetzt, dass wir hier an den Punkten die Fahrwerkskräfte einleiten.
Yeah, maybe I can add here a little bit. This concept of adapting the rear axle carrier directly to the body. We did this also in the M3 GTS and in the M3 CRT. And that's typical for race cars to do that. To take the rubber away and put the axle directly to the body share. But on a race car you have a roll cage with 40 meters of steel and very, very stiff body. And I would say on almost all passenger cars that would not work at all. But the substance and the basis of a BMW 5 Series or 3 Series is so good, so stiff, so strong, that you can implement such concept to a BMW. If you put this on regular cars, that would not make any sense at all. You get all trouble in the world if you do that. But a BMW can stand that concept, like a race car. And this is the best basis you can start from, is a BMW. And this is why an M is such a great car, because we have a BMW basis. Yeah? So if people are wondering, why is it that a BMW maybe is 50 pounds more than whatever, a Mercedes or... I mean, if you look at this, you are getting an idea why maybe a BMW is a little bit heavier, but much, much better performing, stiffer, much more substance. Yeah? This is important to understand. Thanks.
And that we can build race cars. You see that we can build race cars like the GTS and an N. And when we take over the same system in an M5, and the M5 has the demand that it's an everyday use car on the other hand. And so we have to find solutions to bring down the noise, and it was a big challenge that we have an everyday use car, that it's a comfortable car on the other hand, with this performance of a race car. And so we have to find some new solutions, for example, to adapt the rear differential to the axle. It's not only a single, it's now a double connection with rubbers. And with that solutions, with that high performance solution, let me say like that, we have an everyday use car on the one hand, on the other hand, by a switch of a button you can change it to a race car. The question is now to the differential lock system. In our cars before, M3 and the E60, M5, we have a differential, speed-sensitive differential lock system, and only a differential speed-sensitive system. It's good, it's nice, but sometimes a little bit tricky to handle it. How the lock torque will be applied. And so the best solution we thought is to combine a torque sensitive with a speed sensitive differential lock system. And we can do that now, this combination, with the electric controlled differential lock system. So we have it's like the same system inside, the two discs. Then when the electric motor is over there, in that place, there's an electric motor, and this motor pushes together the discs, and then you can lock the system up to 100%. And on the other hand, if you feel, for example, if you're on the brake, it's not good to have a torque between the right and the left wheel, because then you can't regulate it very good. Because you need the left and wheel free are not connected, and in this situation you can open it completely. And then you have no basic torque, nothing. You have an open wheel and the other end. So you can regulate it. So the next point is for cooling. Cooling the rear axle starts not there. Cooling the rear axle starts over there. So because we have to bring the airflow to the end of the car, to our parts, to cool them down and then to bring it out of the car without raiding the car too much. And if you have a good airflow under the car, if there is no turbulences under the car, you have a better cooling, and then the downforce is better. If we have here on close a flat underflow construction at that point. So many points are interesting here. For example, the NACA here influences the airflow to our gearbox. It looks only a hole, but many engineers discussed a lot of time and made many different tests. If this position the best, if that position the best, this is a NACA, it's only a hole. Do we make a shuffle like this or so there are many points I can discuss hours. what is important at the time.
Yeah, regarding the cooling and the airflow underneath, but also on top of the gearbox, very important. So what is unique to the M5, we lowered the whole engine gearbox package by 20 millimeters compared to the regular 5. So that is improvement for the center of gravity also, but also the airflow, because we have the engine with the turbos on top of the engine, so the airflow going over the gearbox, and that was also a big improvement for cooling, going on racetracks, but also for the driving dynamics, to lower the center of gravity.
To lower the center of gravity and to bring it back as far as possible. And when you can take it down the car and have a look in the engine compartment, that you can see the engine is pushed down as far as possible and back as far as possible. That we have maximum load at the rear axle, and then we can transmit our force, if it's enough force in that case, on the Nurburgring, especially under the conditions like that, to bring the force down, and then we have a good performance of the car. So, any questions under the car? Yes, here. What's that? Das ist ein Tilger. Da geht es auch um Geräusche zu tilgen. Das sieht man sogar bei Serienfahrzeugen noch öfter. Da gibt es bestimmte Frequenzen, wo dann auch mit der Zeit Nerven werden. Das machen wir so ein Heulen ganz hochfrequent. Und mit solchen Teilen, das ist Gummi gelagert, beziehungsweise über so einen Kunststoffblock gelagert, bringt man dann genau die Frequenz raus. Ja.
What was the answer, Bernd?
It's an I don't know the English
Counterweight
to compensate.
Yeah,
to
balance
compensate
weight?
the noise from the gearbox.
Noise balance.
Yeah, noise balance.
Is this the only tire that's approved for the car right now?
No, the standard is 19-inch. The Michelin PSS.
Okay.
And now we have to go to the Michelin for the 20-inch.
PSS in both cases. Okay.
It's like a race tire.
Yeah.
Seamlessly.
So I've heard. Yeah.
Die sind miteinander verbunden, der geht oben drüber wie so ein Sattel und wir haben Stahlkante.